Hello, good day. We are about to solve one problem using Smith chart, which is quarter wave and stub impedance matching. The problem is a 75 ohms transmission line is terminated with a load having an impedance of 40 minus J30 ohms. A. Use Smith chart to find the distance in wavelength from the load to the closest place at which a quarter wave transformer could be used to match the line. 3. The first step is to normalize. The formula for normalize is ZL over ZO. The answer is 0.53 minus J 0.4. Next, plot the normalized value to the Smith chart. After plotting point A to the Smith chart, next draw a circle from the origin to point A. There are 2 points where the Seiyin is purely resistive, point B and point C, but the closest distance is point C from A. Next step, extend a straight line outside the chart from the origin to point A. Then extend a straight line outside the chart from the origin to point C. Next step, measure the distance between point A and C. Your point A is 0.424 lambda and your point C is 0.5 lambda. Point A minus point C, 0.5 minus 0.424 lambda is equals to 0.08 lambda. B. Use Smith chart to find the characteristic impedance that should be used for the quarter wave transformer. Zin must be purely resistive closest to A. The normalized value of Zin is equals to 0.44. The formula in finding real value of Zin is equals to normalize Zin multiplied to ZO, which is 0.44 multiplied to 75. The answer is 33, which is the real value of Zin. To find the characteristic impedance ZO is equals to square root of real value of Zin multiplied to ZO, which is square root of 33 times 75 The answer is 49.75. C. Find the length and position of the transformer given that the operating frequency is 20 MHz and the velocity factor for both lines is 0.66. Lambda is equals to 300 over operating frequency multiplied to velocity factor. 300 over 20 megahertz multiplied to 0.66 is equals to 9.9. In finding position, the formula is length multiplied to your lambda, which is 0.08 multiplied to 9.9. The answer is 0.792 meters. Quarter wavelength is equals to lambda over 4, which is equals to 2.475 meters. This is the graph, and this is the solution for the problem. Thank you very much for listening. May you have a good day. God bless.